We have organized our quantitative data, so now let's visualize our quantitative data. We are going to look at two different methods for visualizing quantitative data. The first is a histogram. A histogram is a graph for quantitative data, very similar to a bar graph in a lot of respects. The frequencies or relative frequency is represented by the height of equally sized rectangles. But now with the histogram, we are not going to have space between each of the rectangles. So the horizontal axis is going to contain the outcome of the variable, and the vertical axis is going to contain the frequency or relative frequency. If classes are being used, the class size for the histogram should be the same for the entire graph. Must be the same for the entire graph. So just like with our distribution, we can't decide to go by fives and then all of a sudden have a huge gap and go by 50s. We have to have our histogram go by fives the entire time. We can't just skip a big old number in the middle of the graph. So I have a relative frequency distribution for exam scores. This is very similar data to what we were working with in the organizing data section, but I have tweaked the data just a little bit to make it a little more interesting. So we're going to make a histogram of this data. I'm going to do frequency again. I'm not going to do relative frequency, but just know that I could very easily switch this to a relative frequency histogram and almost nothing would change. So this is going to start pretty much the same as our bar graph. I'm going to start with a horizontal and a vertical line. I actually did my vertical line first, and I want to make these nice and straight. Luckily, my tablet tells me when it's straight. And then I'm going to do little tick marks for each of my rows plus one additional row in my table. So I have 1, 2, 3, 4, 5 rows in my table. So I'm going to do 6 tick marks along my horizontal axis. 1, 2, 3, 4, 5, 6. And I want these to be evenly spaced apart. And I don't want to make these too big. So notice I have a really long line, but I didn't really use that whole line. I could have used a little bit more of it, but I don't want to have these tick marks be really, really far apart like I did on my bar graph. And I don't want them to be super close either. And it'll make a lot more sense as we keep going. But a good, finger width apart when you're drawing this by hand, that's probably about good. And then our vertical axis is going to be the same idea as what we were doing before. So the highest frequency here is 9. So I need to have 9 tick marks or more going up along that vertical axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I like to do one more. That's just what I've always done. 4, 5, 6, 7, 8, 9, 10. And again, we want these tick marks to be pretty evenly spaced apart. Mine got a little wonky there in the middle. This is a lot easier if you're doing this on graph paper or even if you're using technology to help you out. But we're doing the best we can when we're doing this by hand. So I'm just going to clean up my graph a little bit real quick because I don't need all of this extra space that I have. It's actually a pretty small graph that I'm going to be making. And then I can go ahead and put in some labels. So this is frequency. And these down here are going to be exam scores. And then the labels for these tick marks along my x-axis are going to correspond to the first number in each of my rows. So this one is going to be 50, and it's right underneath the mark, and then the next mark is 60, and then 70, 80, 90, and then I said we were going to do one more tick mark because we need one for 100. Even though we don't have 100 in the data set, we have to go one further. Now, the reason why we have to go one further is because when we make our histogram, we're actually going to be reading the histogram more like the other way of writing our classes. So it's more like this notation where we had the 50 up to but not including 60. And then we had 60 up to but not including 70, 70 up to but not including 80, 80 up to but not including 90. And then this last one would be 90 up to but not including 100. So when we make our histogram, we want to think about our classes more in line with this notation as opposed to 50 to 59, 60 to 69. It's a 50 up to but not including 60. So it's time to make the first rectangle. Now this first row, 50 up to 60, had 3 students. So we'll do the whole thing in purple. That sounds good to me. So I'm going to bring my first rectangle. It's going to come up right over the 50, up to the 3. I'm going to come across, and then I'm going to come down right on top of the 60. Maybe. Again, technology is going to allow me to kind of cheat this. So there we have it. 3 people had a 50 up to but not including 60. Anyone who had a 60 would be in the next rectangle. But notice, there are no 60s. Nobody had a score of 60 to 70. So instead of having a rectangle there, I'm just going to leave a gap. I'm not going to draw anything. I'm not going to put a line at the bottom. I'm just going to leave it blank. And now I'm going to repeat the process for 70. So 70, we had 9. So I'm going to come up on my 70 line, and I'm going to come all the way up to the line for 9, which I think is right there. And then it's going to come back down on the line for 80, so I'm going to bring that one up to meet it. And that looks about right-ish. I think my 50 to 60 rectangle is maybe a little bit thick, but that's okay. We're eyeballing this. All right, now I'm going to do the next one. So 80 to 90, up to 90, not including 90, has 5. So when I go to do this one, what I can do is I can come across on the 5 and just bring it right off and then down. And if I were a better drawer, I could do this without messing it up and without having to erase. And this is why, and then I just erase that little bit there, and then I can erase the whole thing. And then that's what it should look like. So it's just coming straight off of the line for 80 and down on 90. So this represents everyone with a score from 80 up to 90. And then I'm going to do the same thing on 3 for the students who have a 90, and I'm going to try and do this properly this time. Oh, there we go. I did it. This is so much easier on graph paper, friends. Let me just tell you that. You do not need to invest in graph paper, but I will just say if you're trying to do this by hand, it's so much easier on graph paper or the dot paper. Dot paper is really nice as well. And then the only other thing we need is a title. So this was the final exam. There we go. The biggest thing to remember with this histogram is the bars of the histogram. It's 50 up to but not including 60. 70 up to but not including 80. If a student got an 80, they're in this column. Anyone who got an 80 is in this column. Anyone who got a 79, they're in this column. So it's a big thing to remember. So that was histograms. We're also going to do stem and leaf plots. We're going to do those next. Right down here. Boop-a-doop. I've got 2 examples of stem and leaves. So stem and leaves is another way to visualize quantitative data. Every data value is split into a stem and a leaf. The leaf is the rightmost digit, and then the stem is any other digits to the, oh no, that's a typo, to the left, to the left, to the left, to the left of the leaf. And then we arrange the data values in order. So we're going to do this with 2 different examples. The first example is a little more straightforward, and then the second example is a little more complex. So the first example here, we have our exam score data set that we worked with in the previous video. So we've seen this data set before. It's the final exam scores for 20 statistics students. So what I want to do to start my stem and leaf is I want to identify the smallest number, which I believe was a 50, and the largest number, which was a 100. So I'm going to look at the smallest number, which is a 50, and I'm going to identify which part of this would be the stem and which part would be the leaf. So the rightmost digit, that becomes the leaf. And then anything to the left becomes a stem. And then I'm going to do the same thing with the biggest digit. That was 100. The rightmost digit is a leaf, and everything off to the left is the stem. So looking at this, I have a stem of a 5 and a stem of a 10, and that is my smallest number to my largest number. So I'm going to set up my chart. I'm going to start by drawing a line straight down the middle. I'm going to label the left side stem and the right side leaf. So on the left side, this is one of those charts that gets really confusing if you tend to mix up your left and rights. On the left side, I'm going to do 5, 6, 7, 8. Woo, that 8 got a little crazy. 8, 9, and 10. So my smallest number had a stem of a 5, and my largest data value had a stem of a 10. So I list 5 to 10 going down my stem. So now what I'm going to do, I'm actually going to cheat a little bit. I'm going to undo my highlighting because I'm going to come back through, and you could do this with just different colors of pen if you had them. I'm going to identify all of the numbers that would have a stem of a 5. And so in this case, because the stem of a 5 represented the 50s, that would be any number that's in the 50s. So that's my 50 and my 57. So now I'm going to write out my leaves in order. So the first leaf is the 0 for the number 50, and then my second leaf is a 7 for the number 57. So the stem is the 50 and the leaf is the ones place. Now I'm going to look for 60s. So the stem, let's actually label this real quick. So the stem are the tens place and the leaves are the ones place. So now I'm looking for anything that starts with a 6, and I don't have anything that starts with a 6. So I'm not going to write anything in that row. I'm not going to erase the 6. I'm not going to skip over the 6. I'm just going to leave the leaf row blank, but I'm going to leave the 6 there so that I can see there are no 60s. And I'm going to move on to 70s. So 74, 77, 75, 72, 72, 77, 76, 72, 73. Okay, there's a lot of 70s. Oh no, there was a 58. There's a 58. I can slap that guy on the end real quick. Woo! Okay. Luckily it was a 58 and not a 56, so it didn't mess up my chart. Hopefully you caught that and you were probably yelling at your screen, "There's a 58!" Like when you're watching a game show and they aren't getting the answer. Okay, so there's a lot of 70s. Hopefully I didn't miss any. And what you could do is you could do like a draft stem and leaf where you just put these out here and you're just like, all right, I got 4 and 7 and 5 and 2 and 2. But I don't want to do that. I want to only make one of these. So what I need to do is I need to write out all of these numbers somewhere. Scratch piece of paper, 7, 6, 2, and 3. Okay, so these are all of the numbers in the 70s. And what I've written down here in blue are just the numbers in the ones place. And I did this because I need them to be in order. Up here, the definition, arranged in order. So I need to put these in order. So that would be 2, 2, 2, 3, 4, 5, 6, 7, 7. Okay, so now that I know what the correct order is for the numbers in the 70s, I can put them in my chart. There we go. So now I can move on and I can do the numbers in the 80s, which I'm just going through right now and identifying them. And then I'm going to come over here and I'm going to write down all of the numbers, 0, 1, 2, 3, 3, 0. Oh, look at that. They're already in order for me. 0, 1, 2, 3, 3. And then the 90s, we've got 92 and 94. And finally, 100. All right, so I think that looks pretty good. I'm still going to check to make sure I didn't miss any. And I'm going to check that by making sure that the number of leaves is equal to the number of data values. So this says we had 20 statistics students. So we have 20 data values. So that means that we should have 20 leaves on our stem and leaf plot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Woohoo! I didn't miss any. I didn't do an extra one anywhere. That can happen, especially like with these 3 2s for the 72. That can happen a lot. So there's one more thing that I want to put on here, and that is a key. A key is helpful because it lets me know that the stem represented tens and the leaf represented ones, because these little arrows that I drew pointing at it, those aren't normally there. Normally we just have the line with the numbers on the left and the numbers on the right. And we have no idea, is this 5.0? Is this 7.2? Is this 7,200? What is this? What are these numbers? So the key lets us know that 5 and then the line and the 0 is the number 50. Not 5.0, not 50,000, just 50. So that's one example. Now we're going to do another example. And in this example, we have GPAs for 10 students, and we're going to do a stem and leaf plot for these ones. Now notice this data, we have 3 digits for each one. And some of them only have 2. One of them only has 2. So we're going to have to deal with all that. So now let's take a look here. Let's find the smallest one. 2.59. Nope, 2.35. 2.35. And what's our highest one? 3.15? I think 3.15 is the highest one. So just like I did last time, I'm just going to switch up the colors. 2.35 is my lowest one. And actually, sorry, I didn't want to switch up the colors yet. 2.35 is my smallest number. So the 5 is going to be the leaf piece, and 2.3 is going to be the stem. And then I can identify this with the 3.15 as well, where again, the 5 is the leaf and 3.1 is the stem. So this would be a great moment for you to pause this video and see if you can figure out how to set up this stem and leaf on your own before continuing on as I go through the stem and leaf. And then you're basically just checking your answer to make sure that you did it correctly. So I'm going to pause for a second so that you can pause the video. Okay, hopefully you actually paused the video and you made the stem and leaf. I should have like a fun little graphic in here that's like, pause the video, but I don't. That's too much production value for me. All right, so our stem goes here and our leaf goes here and we draw a line. I have a feeling I'm going to need a long line because we got to go from 2.3 all the way to 3.1. And we are not allowed to skip any numbers. Oh, actually, that wasn't so bad. I think the first time I did this, I had a much bigger range of numbers. Awesome. All right, and now we're going to throw some leaves in there. Not willy-nilly. So I've got my 2.35. Are there any more 2.3s? No. So just 2.35. 2.4s? Any 2.4s? Nope. So we're just skipping that line. 2.5s. I did see a 2.5 somewhere. 2.5. Any other 2.5s? No. So 2.59. 2.6. Yes. 2.64. 2.7. Ooh, now this is a tricky one because the number says just 2.7. So the question is, what is the third digit to this number? Well, anything in the decimals, if it just stops, we can fill in those empty decimal values with zeros. So 2.7 is the same as 2.70. So this guy would be 2.70. Because we have a data value here, so we can't just leave it blank. We do need to put a number here. Otherwise, we won't have the number of leaves equal to the number of data values. So we needed to figure out something to go there. And we did. All right, 2.8, 2.81. Okay, there's a whole lot of ones in this one, like only one leaf. I think we're finally going to get to do something exciting here. 2.99, 2.99, and 2.91. Woo! So 2.91, and then we have two 2.99s. Now, I'll make a comment here. Sometimes you'll see commas in the leaves when there's multiple values. That's totally fine. I personally don't like it. I think it looks busy, but it is absolutely fine to put commas in there. All right, getting down to the end, 3.02 and 3.15. Count up our leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. And our key, 2.3 line 5 equals 2.35, and it's just 2.35. This could have represented dollars, so this could have been like 2.35 million, and that would be important. That would be a very important thing to include in the key if this was 2.35 million, but it's not. It's just 2.35 because it's a GPA. So there we go. Those are stem and leaf plots. Important things to remember, only one digit in the leaf per data value. You should have a leaf for every data value. And the numbers need to go in order. And no skipping stems. This was fun.